Welcome to NASA LaunchPad. I'm your host, Max Henry. So by now, you've heard that America's heading back to the moon. You might be thinking to yourself, big deal, right? You've been there before. Well, guess what, guys? It really is a big deal. And there's a lot to be gained from going back to the moon. Think about all the equipment we'll need to get us back to the moon. You may say, but what about all the equipment used in the Apollo missions? That worked fine before. Couldn't they just use it again? Sure. If you want to go back to using a record player and an 8-track, and you probably don't even know what that is. It's cool. In 1969, when Neil Armstrong and Buzz Aldrin landed on the moon, people listened to music by playing records on record players and 8-track tapes on, got it, 8-track players. These days, we're listening to music on CDs, MP3 players, even our cell phones. So if the technology for how you listen to your music has changed this much, imagine the changes in the technology to take people back to the moon. Getting back to the moon will be safe and more efficient than ever before, which is cool. And what about when we get there? No more quick visits. NASA's got big plans. Alright, the plan is for astronauts to stay longer on the moon, actually living on the moon. This way they'll have more time to perform scientific experiments and experience what it's like to live away from Earth for longer periods of time. What kind of gear does it take to work on the moon? Well, if you were in Moses Lake, Washington recently, you got a good look at some of the technology NASA's testing for possible lunar use. But odds are, we're not there. So let me show you. Moses Lake was an ideal choice for lunar testing because, although it's still under the force of regular Earth gravity, the terrain is very similar to that of the moon. What do you think the surface of the moon might look like and feel like? Lunar dust, called regolith, is very abrasive and has sharp, jagged-edged pieces that can even scratch camera lenses. Oh, and did I mention it sticks to everything? The particles have a static charge, the same kind of static you use to zap your little brother on a cold, dry day. The static is also a problem for machines, such as jamming mechanical joints. The dirt and dust of Moses Lake isn't as much of a problem as the moon's regolith, but traveling over the surface of the Earth here at Moses Lake gives us a good idea of what it might be like to travel over the moon's surface. Now, let's get into the gear. Take a look at the athlete. Athlete stands for All-Terrain, Hex-Legged, Extraterrestrial Explorer Robotic Rover. And what's it for? Well, even though the moon's gravity is only 1/6 of the Earth's, there's still a lot of very heavy equipment and materials to be lugged around. And that's where the athlete comes in. Using its 6 wheels and legs to function as a rover, or robot, it could trek over the rough rolling terrain of the moon as it transports up to 450 kilograms, 992 pounds, of cargo at a potential 10 kilometers per hour, about 6 miles per hour. Super speed compared to Mars rovers. Actually, that's over 100 times faster than the exploration rovers currently on Mars. Here's another vehicle currently being tested, the Chariot. Now, this bad boy is powered by 2 electric motors and features a 2-speed transmission. The Chariot, or lunar truck to its creators, is the next generation moon buggy. Each of its wheels can pivot individually in any direction, allowing it to move in all directions. The 2 turrets allow astronauts to rotate 360 degrees, and with its lance blade attached, it can act as a bulldozer with the ability to push about 1,800 kilograms, nearly 2 tons of material. Top speed, a blazing 24 kilometers per hour, or 15 miles an hour. But hey, that's quick for the moon. There's 12, count them, 12 wheels on the Chariot. Why so many? Well, think about it. The old rovers had 4 wheels. Can you imagine getting a flat on the moon? Good luck getting a tow truck. With more than 4 wheels, you're able to keep going with a flat, and the more wheels, the better, of course. And obviously, you got to be able to steer the thing so you can avoid getting those flats. Steering the Chariot is a different experience than steering your car. It's called crab steering, and it's designed to allow astronauts to drive into the moon's craters. Too steep? No problem. The all-wheel, always steering allows the vehicle to drive sideways, so no more backing up or 3-point turns required. Of course, since the vehicle can move in any direction, the driver's perch needs to do the same, so the driver will be able to turn and face whichever way the rover is headed. Now, all of this work is being done by the Exploration Technology Development Program Office at NASA, ETDP to their friends. They help get us there, developing technologies to get America back to the moon and who knows where else. Quick question for you before I go. You saw all the guys in spacesuits out at Moses Lake, right? Well, could you tell the difference between the real suits and the props? That's right, props, as in movie props, as in Hollywood. NASA spacesuits are pressurized, which basically makes them their own self-contained spacecraft. The pressurization is great when you're on the moon, but they're heavy and bulky if you're working here, on Earth that is. So NASA hit up Hollywood and had some unpressurized suits made. These prop suits were much lighter than the real suits, but still helped to test ease and efficiency of motion. The Hollywood suits were also more like the weight and feel of those suits once an astronaut gets into 1/6 gravity. So the work in Moses Lake felt similar to work on the moon. Plus, the Hollywood suits didn't have to be of a charge like a pressurized suit, so work didn't have to stop as often. And those are just a few of the potential technologies and equipment our astronauts might be using on the moon. And who knows, someday you might just find yourself taking the chariot out for a spin and do some donuts in a lunar crater. That's it for now. Until next time, I'm Max Hennard, and thanks for watching NASA LaunchPad.